Hi everyone. In this video, we will learn about prefixes and equalities. Our learning goal is to use the numerical values of prefixes to write a metric equality. And many of you in your everyday lives work with different prefixes and units. For example, we can see an ophthalmologist taking photographs of the retina of the patient's eye using a retinal camera. And there will be units and prefixes associated with the different measurements that the doctor is taking. So what are prefixes? A special feature of the SI system, as well as the metric system, is that a prefix can be placed in front of any unit to increase or decrease its size by some factor of 10. For example, the prefixes milli or micro are used to make the smaller units. And so when we're working with the metric system or the SI system, we're working with factors of 10. And the prefix is in front of the unit. So for example, we discussed in a previous lecture video that the units for mass were either grams or kilograms, depending on which system we're using, but we will stick with grams. And that milli implies a much smaller value. That prefix is going to tell us how small that gram is. Same with microgram. And when you learn prefixes, there will be abbreviations. So for example, milli will be the lowercase m. Micro abbreviation will be the Greek letter mu. And this will be a core chemistry skill to master when using prefixes. So there are prefixes that increase the size of the unit, and we'll talk about those first. So for example, the more common one you may be familiar with is kilo, which is abbreviated lowercase k. And it makes the unit 1,000 times bigger. So for example, if I have 1 kilometer, then that is 1,000 meters. So kilo represents 1,000. Now with these example equalities in the table, you notice that the units at the end are changing. They're interchangeable. So for example, I could have easily have said that 1 kilogram is 1 times 10 to the third grams. Now, when I work through problems in this video and in future videos, I tend to use this equality here where I do not have to worry about negative exponents. However, this equality below, this example, is saying the exact same thing. That 1 meter is 1 times 10 to the negative third kilometers. But like I said, I usually will focus on the equality that does not have a negative exponent. So for example, since kilo makes things bigger, then the 1 times 10 to the third is in front of the meters. The next prefix is mega, and that is represented by a capital letter M. And that is a million, or 10 to the 6. So 1 megagram is equal to 1 times 10 to the 6 grams. That mega represents that value there. Giga is a billion, or 1 times 10 to the 9th. And so 1 gigameter is equal to 1 times 10 to the 9th meters. Tera is 10 to the 12th. And so if we're looking at 1 terasecond, that's 1 times 10 to the 12 seconds. You may be more familiar with terabytes for memory storage. And then peta is 1 times 10 to the 15th. The most common units we will be using are kilo, mega. Some of your homework problems may have you practicing with some of the larger prefixes. There are also prefixes that will decrease the size of a unit. And those prefixes are deci, centi, milli, micro, nano, pico, femto. And here are their abbreviations. And so, for example, deci, we have 1 liter is equal to 10 deciliters, because deci is 10 to the negative 1. So for example, 1 deciliter is equal to 1 times 10 to the negative 1 liters. And if you were to take this number and divide by that number, you would get 1 liter is equal to 10 deciliters. So once again, when I memorize the prefixes, I usually use the ones that do not require any negative exponents. So 1 liter is 10 deciliters, or 1 meter is equal to 10 decimeters. You can always interchange the unit at the end. Centi is 10 to the negative second. So 1 centimeter is 1 times 10 to the negative second meters. But the way I learned it was 1 meter is equal to 100 centimeters. For milli, it's 1,000. So 1 second is equal to 1,000 milliseconds, or 1 gram is equal to 1,000 milligrams. Micro is 10 to the negative 6. So 1 microgram is 1 times 10 to the negative 6 grams, or 1 gram is 1 times 10 to the 6 micrograms. Nano is times 10 to the negative 9th. 1 meter is 1 times 10 to the 9th nanometers. Pico is 10 to the negative 12th. So if we were working in seconds, 1 second is equal to 1 times 10 to the 12th picoseconds. And then femto is 10 to the negative 15th. So if we're working in seconds again, 1 second is equal to 10 to the 15th, or 1 times 10 to the 15th femtoseconds. More often than not, you're primarily going to be working with deci, centi, milli, and micro in my class. But some of your problem sets may have you practicing with nano, pico, and femto as well. So as I have shown in those tables, the relationship of a prefix to a unit can be expressed by replacing the prefix with its numerical value. For example, when you hear the prefix kilo in kilometer, it is replaced with its value of 1,000. We find that a kilometer is equal to 1,000 meters, or 10 to the 3rd meters. A kiloliter is 1,000 liters. A kilogram is 1,000 grams. And so these prefixes represent a numerical value. What helped me as a student was making flashcards to memorize what each prefix meant. And then, because it's like learning a new language, that becomes part of your everyday vocabulary. So I encourage you to either practice with flashcards or maybe create a Quizlet online so that you can begin to learn and to memorize the different prefixes and what the numerical values they represent. The sooner you do that, the faster you will get when we begin problem solving together. And just as an example, when you're looking at, different ingredients, maybe in the foods that you eat, the US Food and Drug Administration uses those metric prefixes to express amounts of daily nutrient requirements. And now you can start to think about, oh, what prefixes is this? So for example, the daily values of selected nutrients, the amount recommended by the FDA for protein is 50 grams a day, vitamin C, 60 milligrams, Vitamin B12, 6 micrograms. Another abbreviation for micro is little m, but we will use the mu symbol. And you can see all the other nutrients that we need in our daily diet using the metric system. So pause the video and try to do this problem on your own using the tables in the previous slides, and then come back and check your work with me. All right, welcome back. So we need to fill in the blanks with the correct prefix. So 1,000 meters is equal to what? 1 kilometer, good. So you should put a K right here, since a K represents 1,000. 1 times 10 to the negative third grams is equal to what? Excellent, 1 milligram. How would we write this so that we didn't have to use a negative exponent? 1 gram is equal to 1,000 milligrams. And the way that you could derive that, if you're like, wait a second, is this a different equality? No, it's the same, and you can always derive it from the original. So let me show you how to do that. So if you take 1 times 10 to the negative third grams equals 1 milligram, then you could divide both sides by 1 times 10 to the negative third. On the left side, 1 times 10 to the negative third cancels out, and so we are left with 1 gram. And 1 divided by 1 times 10 to the negative third ends up being 1 times 10 to the third milligrams, which is essentially 1,000 milligrams. So if you do find it easier to memorize, the negative exponent prefixes, but you want to work with maybe the positive, no negative exponents, like in the word problems, when we start to use these equalities as conversion factors later on, you can always derive it from the original equality. All right, and then 0.01 meters, what did you get for the prefix? Good, that is 1 centimeter. And once again, if we were to divide both sides by 0.01, we get 1 meter is equal to 100 centimeters. So as I alluded to in the earlier example, ophthalmologists measure the diameter of the eye's retina, and they measure in centimeters, while a surgeon measures the length of the nerve in millimeters. And so we may have to go between multiple units. So each of the following equalities describes the same length, but in different units. So for example, 1 meter is 100 centimeters, or 1 times 10 to the second centimeter. So this is just written in scientific notation. 1 meter could be 1,000 millimeters, so 1 times 10 to the third millimeters. And 1 centimeter is equal to 10 millimeters, which is 1 times 10 to the 1 millimeters. And so once again, many of you plan to work in the medical field. And so you will be working with different units all the time. So for example, if I was working with the ophthalmologist, I would need to provide the data in centimeters. But if I was sharing results with the surgeon, I need to provide data in millimeters for that nerve, for the length of the nerve. So it's important we feel comfortable going between different units and using those prefixes. So that was for measuring length. Once again, we can use prefixes for any unit, any measurement. So measuring volume. So volumes of 1 liter or smaller are common in the health sciences. When a liter is divided into 10 equal portions, each portion is called a deciliter. And so some examples of volume equalities that we will use is going from 1 liter, which is 10 deciliters. 1 liter, this one's going to be really common. 1 liter is 1,000 milliliters. And if you wanted to convert directly from a deciliter to milliliter, it'd be 1 deciliter is equal to 100 milliliters. And so in the medical field, these are some typical laboratory test values. So for measuring, for example, cholesterol, looking at 105 to 205 milligrams per deciliter. If we're looking at the amount of iron in a male, it's about 80 to 60 micrograms per deciliter. Another unit of volume that we will come across is the cubic centimeter, and it's abbreviated as centimeters cubed or cc. And it's the volume of a cube whose dimensions are 1 centimeter on each side. A cubic centimeter has the same volume as a milliliter, and the units are often used interchangeably. So for example, 1 cubic centimeter is 1 cc, which is 1 milliliter. This is a very important equality to remember, that they're all the same. And that means that 1,000 cubic centimeters is 1,000 milliliters, and this is 1 liter. This is showing you an example of a plastic intravenous fluid container containing 1,000 milliliters of solution. So how did we know that 1,000 cubic centimeters was 1,000 milliliters? Well, we have a cube measuring 10 centimeters on each side. And if you take the volume of a cubed, the volume of a cubed is length cubed, each of the lengths, which are the same because it's a cube, so, and then it's cubed. And so for example, if we divide these up into little cubes and they were measuring in 1 centimeter, then it'd be the volume of each individual cube would be 1 cubic centimeter. If we measured the volume of the bigger cube, then each side is 10 centimeters. So that's 1,000 cubic centimeters, which is the same as 1,000 milliliters, which we know is 1 liter. And some of you may work with syringes. And so this is an example of a 5 milliliter syringe. And that if we need to deliver 1 milliliter of something of a solution, then that's the same as delivering 1 cubic centimeter or 1 cc. So there are different units for expressing volume. Another measurement we will be doing is measuring mass. For example, when you visit the doctor for a physical examination, they record your mass in kilograms, and the laboratory results that they record for different measurements are done in micrograms. And so examples of equalities between those different metric units of mass are as follows. So we know that 1 kilogram is 1,000 grams, 1 gram is 1,000 milligrams, 1 gram is 100 centigrams, 1 milligram is 1,000 micrograms. And so, like, once again, just feeling comfortable going between the different prefixes is crucial. And later on in a future video, I will teach you how to use a technique called dimensional analysis. That will help you convert between different units confidently. But for right now, at this point, I want you to begin studying those tables that we looked at earlier and feel more comfortable with what each prefix represents as a numerical value. So let's do that. Let's practice Please pause the video and come back and check your work with me. All right, welcome back. So our goal for the study check was to identify the larger unit in each of the following. So looking at millimeters or centimeter, which one is larger? So which one would you say is the larger unit? Good, awesome. Hopefully you said centimeters. And then if you wanted to write some equalities to prove that to yourself, you could kind of reference it. Say 1 meter is equal to 100 centimeters. And 1 meter is equal to 1,000 millimeters. And so therefore it looks like, both of these measurements is for 1 meter. It takes fewer centimeters than it does millimeters. So this must be the larger unit, the centimeter versus the millimeter. All right, what about kilogram or centigram? Good, yeah, kilogram is definitely larger. It's one of the prefixes that makes things larger. So for example, for 1 kilogram, that's 1,000 grams. But for 1 gram, that is 100 centigrams. So kilo is definitely the larger prefix, making it the larger unit. What about milliliters or microliters? Excellent. Milliliters is the larger unit. And if we go back to our table, we can also refer back to the table as we're practicing problems here. And you can see, for example, milli was 1 times 10 to the negative third. Micro is 1 times 10 to the negative 6. So that's why milli is a lot larger compared to micro. What about kiloliter or microliter? Definitely kiloliters. So kilo is one of those units that makes things larger. Micro makes it smaller. So kilo is definitely the larger unit. All right, thank you for watching and email me with any questions.